Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Based on the response I received for the lectures on refrigeration systems, I am presenting here with a series of lectures on psychrometry, again for the benefit of the students and the professionals. I believe these lectures will also add a great value to all of you. This is the second lecture in the series of lectures on psychrometry. In this lecture, we will discuss both psychrometric chart as well as psychrometric processes. However, let me start with psychrometric chart. Psychrometric chart is a summarization of all essential data that is needed for the complete thermodynamic and psychrometric analysis of air conditioning process. It has dBT on x-axis and specific humidity or W on its y-axis. This is the saturation curve. If the state of the moisture is falling on this line, then it will have its RH value equal to 100% and the dBT, WBT and dew point temperature of this air will be same. All vertical lines are constant dBT lines. All the horizontal lines are constant specific humidity lines. These are the constant relative humidity lines. Whenever the state of the moisture moves towards the right, then its relative humidity value decreases, and whenever the state of the moisture moves up, then its relative humidity value increases. Next, these are the constant enthalpy lines, and the WBT also remains constant along these lines. And finally, these are the constant specific volume lines. There is an important note point about psychrometric chart. That is, a psychrometric chart is constructed for a given barometric pressure. Means, the psychrometric chart that is used at Hyderabad cannot be used at Ladakh because the barometric pressure at Ladakh will be lower. Let us look at the reason for this complexity. It comes from the Gibbs phase rule, which says that F is equal to C minus P plus 2, where C is the number of components, P is the number of phases. In case of the moisture, it has two components. One is dry air and other one is water vapor. So, C is equal to 2. And both dry air and water vapor exist in gaseous phase. So, number of phases P is equal to 1. This would result in F is equal to 3. Means we need 3 properties to plot the state of the moisture on any coordinate system. But by fixing the barometric pressure, we could plot the state of the moisture with just 2 properties. This is the reason why the psychrometric chart is constructed for a given barometric pressure. Let us now see how to read the psychrometric chart. I know many of you are aware of this, but let me do it just as a formality. Let the state of the moisture given to us be 25 degrees centigrade and 50%. Let us now plot this state of the moisture on the psychrometric chart and then read the remaining properties from the psychrometric chart. So, we first identify the 50% RH line and then the dBT is equal to 25 line. The intersection point 1 is the location of the given moisture plotted on psychrometric chart. From state point 1, if we go horizontally towards the right, gets us the specific humidity. And if we go horizontally left, and after hitting the saturation curve, we go down, will get us the dew point temperature corresponding to state point 1. The constant enthalpy line that is passing through the state point 1 gets us the enthalpy H1. From the constant enthalpy line, we can get the WBT corresponding to state point 1. The constant specific volume line that is passing through the state point 1 gets us the specific volume of the moisture corresponding to state point 1. This is how we will be plotting the state of the moisture with just two properties, and the remaining properties can be read without doing any calculations. The next important parameter we need to know is the wet bulb depression, WBD. And this is equal to dBT minus WBT. For the given moisture, the WBT would be 18 degrees centigrade. Therefore, the WBD for this moisture would be 25 minus 18, 7 degrees centigrade. As discussed in the previous lecture, for saturated air, all the three temperatures would be equal. Hence, the WBD for saturated air would be equal to 0. Let us now discuss about the psychrometric processes. There are 4 basic processes in psychrometry. Whenever the dBT of the moisture is increased while keeping its W constant, then that process is called heating, simple heating, or sensible heating. On the other hand, whenever the dBT of the moisture is decreased while keeping its W constant, then that process is called cooling, simple cooling, or sensible cooling. The next, whenever the W of the moisture is increased while keeping the dBT constant, then that process is called humidification. Finally, whenever the W of the moisture is decreased, keeping the dBT constant, then that process is called dehumidification. These are the 4 basic processes that are there in psychrometry. Let us now have these processes plotted on the psychrometric chart. Let 0 be the initial state of the moisture. Both for heating and cooling, the W is constant. Therefore, these two processes happen along the horizontal line in the psychrometric chart. So, whenever the state of the moisture moves horizontally towards right, then it is said to have undergone the heating process. And whenever the state of the moisture moves horizontally towards left, then it is said to have undergone the cooling process. Both for humidification and dehumidification, the dBT is kept constant. Therefore, these two processes happen along the vertical line. So, whenever the state of the moisture moves up vertically, then it is said to have undergone the humidification process. And whenever the state of the moisture moves down vertically, then it is said to have undergone the dehumidification process. There are 4 more processes in between these 4 basic processes. Let us now look at them. Whenever the state of the moisture is moving along 0,5 line, then the state is moving towards right, hence heating, and moving up, hence humidification. Therefore, heating and humidification is the process undergone by the moisture here. Whenever the state of the moisture is moving along 0,6 line, then the state is moving towards left, hence cooling, and moving up, hence humidification. Therefore, cooling and humidification is the process undergone by the moisture here. The next, whenever the state of the moisture is moving along 0,7 line, then the state is moving towards left, hence cooling, and moving down, hence dehumidification. Therefore, the cooling and dehumidification is the process undergone by the moisture here. Finally, whenever the state of the moisture is moving along the 0,8 line, then the state is moving towards right, hence heating, and moving down, hence dehumidification. Therefore, heating and dehumidification is the process undergone by the moisture here. These are the 8 processes that are used in psychrometry. The important note points: simple dehumidification is not possible to achieve. That is, process 04 cannot be achieved in psychrometry. The dehumidification process must be accompanied either by cooling or heating. The next, heating and dehumidification process number 08, is also called chemical dehumidification process, and it can happen only when the air is passed through a chemical bed. Let me now take you to the special process in psychrometry. As discussed in the previous slide, and if 0 is the initial state, then the state of the moisture can move in any of these 4 directions. If I mark this as 0 degrees, then the remaining 3 will be 90 degrees, 180 degrees and 270 degrees. If the state of the moisture is moving along the 0 degrees line, then the moisture is said to have undergone heating process. Similarly, for others, we have the humidification, cooling and dehumidification processes. But if the state of the moisture is moving in the first quadrant, that is between 0 and 90 degrees, then the moisture undergoes heating and humidification process. Similarly, for quadrant 2, it is cooling and humidification. For quadrant 3, it is cooling and dehumidification. For quadrant 4, it is heating and dehumidification. We discussed all these in the previous slide itself. I am just trying to put it in a different way. Now, let me take you to the special process called adiabatic cooling or adiabatic humidification. As discussed in the previous lecture, the adiabatic process in psychrometry happens at constant enthalpy, and the same is happening here. Adiabatic cooling is a psychrometric process during which the moisture gets cooled and humidified while keeping its enthalpy constant. The moisture undergoes cooling and humidification process, and hence it will be in the quadrant number 2 only. But all the processes that lie in quadrant 2 undergo cooling and humidification process. However, only that cooling and humidification process which happens at constant enthalpy is called adiabatic cooling or adiabatic humidification process. During this process, the WBT also remains constant. If the state of the moisture is moving in diagonally opposite direction, then it is called adiabatic heating or adiabatic dehumidification or chemical dehumidification process. It is defined as a psychrometric process during which the moisture gets heated and dehumidified while keeping its enthalpy constant. We can have the air heated and dehumidified in 2 separate processes. Like, we can have the air dehumidified first and then heated to the required temperature. But during adiabatic heating process, both heating and dehumidification of moisture will happen in one pass only. And that is possible only when the moisture is passing through a chemical bed. The chemical dehumidification process is gaining popularity these days. However, the adiabatic cooling process has an application that is very familiar to all of us. The evaporative air cooler adapts or uses the adiabatic cooling process. With this, this lecture is completed. In case you have any doubts, questions, clarifications, etc., please feel free to write to me. The next topic will be on air washers. See you then. Thank you very much.